Hey all. That was a little bit of a rushed start, but my name is Leo and I'm working on the developer tools team at 0x. And we as a developer experience team, we care about developer experience, and we've developed some tools that will make the developer experience better. And today I want to present those tools. It all started at ETH Denver, where me and Remco were working on the Solidity profiler, and here we're presented on the CryptoKitty smart contract, and on the left you see the gas costs for different lines. It was a little bit of an experiment, a little bit of a hack over there, but people liked it and we liked it, and we started working on that more. So first, let's go to the agenda. I'm going to talk about the list of tools that we're presenting today and the functionality of those tools and why are they improving the developer experience. Previous work in the area of similar tools, how they work, how they function from inside, and integrating those tools with your favorite frameworks because they're framework agnostic. So without further ado, let's jump right in. SolTrace. SolTrace is the tool that gives you human-readable stack traces for Solidity. I think everyone who have ever wrote Solidity encountered an error in Solidity, and when you have an error, it's not much you can do to debug that error because you get a transaction hash and then revert. If you're lucky, you get the revert reason, which is a string. But then that doesn't always work for you because sometimes you have a contract A that calls a contract B, and then the contract B has the revert string, for example, overflow, and you don't know what did overflow and why did it overflow. That's an example of a terrible developer experience, and it shouldn't be like that. In other languages, it is not like that, and you just get a normal stack trace, and you can use it to debug your code. There's even a page where you can go, which is called VM exception while processing transaction on revert, which is hilarious and has some good examples of how to debug that stuff and how it's impossible to debug that stuff. And I was motivated by that page when working on that tool. But now at the top of that page, they just have the link to SolTrace, which solves your stuff. Yeah, so here is the example of the truffle error message that says you check that your code satisfies all the conditions by require statements, which can be really hard when you're working on a huge system of smart contracts that has a lot of those require statements. And at 0x, we've hit that complexity limit. So we started thinking, how can we do better? And it appears that we can do better. We can just get Solidity revert traces. And now you can do too. So here is the example of the revert trace that you can get with this tool. And we have two smart contracts here. And contract MetaCoin used SafeMath, quite a common pattern. And then SafeMath has some overflow checks. And even if we have the revert reason here in the overflow check in SafeMath, it will say something like overflow or subtraction failed. But you don't know what is that subtraction, why did it fail? And here you know that MetaCoin on the line 13 called that SafeMath with the message sender balance and the amount. So this is already much more helpful for you to debug why did it revert and how you can fix that. So you should look into the balances of message sender. The second tool is the tool for code coverage. I don't think there is anything to explain here because it's just code coverage, and we all need that to test our code and to check how well did we test our code. The problem was that in the Solidity world before, that was not very feasible. But now you can just use that tool. And the good part about it is that it generates the report in the Istanbul format. And Istanbul is this popular code coverage tool in the JavaScript world, which can generate reports in text format, JSON formats, HTML format, so whatever, you name it. So we didn't need to rebuild all of that stuff from scratch. We just generate the file. You run the Istanbul reporters to get your coverage report from that file. And you can easily integrate it in your CI pipeline and other tools that work with coverage. That's just seamless. Third tool, it's the profiler for the Solidity. In the Solidity world, code consumes gas, and gas is money. And what's even worse, gas is your client's money. And you shouldn't be spending a lot of your client's money because then they're not going to like you too much. But if you want to optimize your code, you'd better know what are the problems with your code, what are the places where you should optimize it. So Solidity Profiler shows you how much gas did each line consume. So here, for example, we see the example of the deposit contract. I think that's the Ethereum contract. And the line with the balance off consumes a little bit over 20,000 gas because that's a storage right, and storage rights are expensive on Ethereum because every node stores that data. So it's a little bit over because it also has some additions and some reads from the call data or something. But the next line is the event, and the next line is much cheaper because events are much cheaper than storage writes. So here you can see that overall this function consumed 21,000 gas, and those particular lines consumed that much gas, which may help you debugging your contracts and optimizing them for gas cost. The other use case of that tool is for the Solidity team itself. We contacted them, and they were interested in that for tuning the Solidity optimizer. Because now you have this runs parameter on the Solidity optimizer, which helps the optimizer to make the trade-off between the code size and the gas cost of the code. Because the optimizer can do different optimizations, but the optimizer needs to know like what is good, what is bad, and how to decide about it. If you have the tool like that, you can show the optimizer that this function is executed very frequently, so you'd better optimize it. But this function is not executed very frequently, so you shouldn't care about it. So we can run that, for example, on the mainnet, get the statistics for the contract, and deploy a new, more optimized version of that contract while providing this data to the Solidity compiler itself. So talking about the Solidity compiler. Solidity compiler is nice, but it should be a little bit more higher level. It's not the responsibility of their team, so we built a higher level Solidity compiler wrapper called Sol compiler. It's like Solc, but with batteries. So what's batteries about it? It's project-centric. It compiles all the files for you. It has the watch mode, and that's the only Solidity compiler I know that has the watch mode. Like all the modern compilers, it just watches the file changes and recompiles them for you as you change them in the IDE, making the developer experience much more seamless. It's fast because it works with the Dockerized Solc as well as the Solc.js. You choose which one to use, but on the big projects, Dockerized Solc is literally like 10 times faster. Has incremental builds, so it doesn't rebuild the stuff that didn't change and only rebuilds the stuff that changed and its dependencies. And it also supports multiple versions. So if you have a project where you have one contract with the version 0.422, 0.425, it will figure it out, solve those constraints, and compile them with different versions. As far as I'm concerned, a lot of other frameworks don't allow you to do that. And it also works with monorepos. As you go to a more and more complex software and systems of smart contracts, a lot of teams start migrating to monorepo, and we're using the monorepo ourselves, and Sol compiler supports the monorepo. Other good thing is customizable artifacts. I think everyone who've used Truffle seen those huge artifact files, which have the AST, legacy AST, assembly, bytecode, stuff like that. Sometimes you just want ABI because you're deploying those artifacts and you care about the bundle size. Sometimes you actually want all of that stuff if you're debugging. Here, using the Solidity input JSON and output format, you can just specify what do you want in your artifacts and get just that without any trash on the side. So those are the 4 tools. Here's some previous work. There were some compiler wrappers with different versions of success, but in terms of coverage, tracing, and profiling, I haven't found anything except for Solidity coverage, which is the tool written by the Truffle team, Chris Gewecke, if I'm not mistaken. And this tool also has an interesting approach, but we've had some problems with it, and that's why we reinvented the wheel. So the approach of this tool is it takes your source files and it instruments those source files. Before each line, it adds the event. It adds this line covered event, like you see here. You have a equals a plus 1, and after that you have emit line covered 1. 1 is for the line number, and then a equals 1 plus 1. Then it recompiles all of your contracts. Then it runs the tests through the forked VM with the forked ganache. Why forked? Because you need enormous gas limit for that, because events consume a lot of gas. And also in order to track coverage for calls, because you can't get debug traces for calls, they just write those directly from the VM to the text file on your machine, and then read the text file. It's a nice hack. I like it, but it wasn't very reliable for us. It was also slow, and I didn't like running those forked versions and configuring all of that. Was a little bit hard for me. So that's why we went with the approach that I will describe later. So our approach is mostly using debug traces. And debug traces is the stuff that you get from the node or from the virtual machine after executing the transaction. And it has some interesting data. So for each operation, and by operation I mean the opcode execution, it has the program counter, PC, which kind of translates to the line of assembly you're executing. So here you see those incrementing program counters. It has the operation, which is the opcode you're executing, and it has the gas cost and the call depth of that opcode. So with this information from the VM directly, you can do a lot of useful stuff. And that's available on each Ethereum node, so you can just get it for every transaction. But then program counters are not very useful if you can't translate them back to the source code. Luckily, Solidity gives you the source maps. They look like that. I'm not going to explain how they work because it is in their documentation and it's not very interesting. But basically, this magic string allows you to translate the program counters to the lines of code. And then with that information, you can already write the coverage tool and the profiling tool. You can just get the gas costs, map them back to lines of Solidity. Here you go. Get the operations, map them back to lines of Solidity, and you know which line was executed and which line was not executed. But then if you want to do more interesting stuff like revert traces, then you need to start tracing subcalls and emulating subcalls. Luckily, we can also do that with the debug traces. You just need to see where the opcode is call code, static call, delegate call, and kind of like emulate that call. So you record where you jump, and then when you return or revert, you pop that back from the stack. That's how you reconstruct the stack, and when the revert happens, you know like where you jumped, and you can map that back using the source lines and get the nice revert traces that we had here. Yeah, so if you like any of those tools and want to start using them, the good news is they're not written for any particular framework. They're just providers that you can connect to your provider engine. They're framework agnostic. And you can add your own artifact adapter for those tools because they need to know something about your smart contracts. They need to know the bytecodes, the source maps, and the source codes. They use those source maps to map the bytecode back to the source codes. They work out of the box with the Sol compiler and Truffle because we just wrote those artifact adapters. But you can use it as an example to write your own artifact adapter. So for example, the Waffle team currently works on the artifact adapter for the Waffle framework. And if you use any other tooling, you can also use those tools. No vendor locking here. Resources. So if you're interested and want to read more about those tools, I recommend to start with the blog post we recently published about those new dev tools. There are also 4 landing pages that are general high-level explanation. What are those tools and how to use it and why do you want to use it? Sol trace, Sol coverage, Sol profiler, and Sol compiler. Not so hard to remember URLs. And there are some documentation pages that go in depth of how to use those tools, how to write your own artifact adapters, how to use them with the different frameworks, so more nitty-gritty technical details. Yep. That's kind of it that I wanted to talk about. So I guess from now the developer experience on the Ethereum can be just a little bit better.